Qwen 3.8 27B was released yesterday, and it's not an improvement over Qwen 3.6 27B. In an apples-to-apples model switch, I've measured it to use twice as many reasoning tokens as its predecessor on a wide array of software engineering tasks, not just the harder ones. This is a massive efficiency loss for Qwen 3.8. On this channel, we use facts and analysis to examine large language models. I've put the model through extensive automated tests. I've used it hands-on. I got up early yesterday at 8 a.m. to download it as soon as it came out. I've sent roughly 50 million tokens through the model, and I've gotten about 1.5 million tokens out. And the headline finding is that this model thinks too much. Out-of-the-box configuration for reasoning is absolutely indefensible. It makes the model slow. It performs worse than 3.6 on some hard tasks due to thinking too much. I've got cases where 3.8 absolutely destroys its predecessor as well. It's possible that with the right configuration, it can do a better job. That's guaranteed, actually. You can definitely make it perform better with some fine-tuning of your runtime. But if you hand this off to the public as the default settings, and then it's slower and it thinks more, and it does worse, like, what are we doing here? Now, the bright spots. Okay, Qwen 3.8 is a major upgrade in vision. You can pass the thing an MP4. If you're using llama-server and you've got FFmpeg installed alongside of it, it can parse MP4s, and this is a really cool capability. It's also just better at dumping structured information from images, I think. And we'll look at specific examples of that with a chessboard and getting the fen notation out of an image, and Qwen 3.6 just can't do it at all. So, and in addition, the model solved a hard problem in my task set that no other model in its class did. But even that has some caveats to it. So, what are we going to cover in this video? First, we're going to look at the comparison to in-class models. That means Fable Fusion 711. That means Muse Glimmer 30B. That means the 35B-A3B Qwen 3.6. And we're going to focus on reality and facts, but we are going to spend 30 seconds looking at some hype, too, for comparison. We're going to get specific on the prompts and tasks where 3.8 excels and where it utterly falls on its face, so you can try them at home. In addition, we'll also cover some of the quirks in its reasoning style and some stylistic analysis. It's got a lot more love for M-dashes with the new release. There's new characters that it's emitting. They're called vulgar fractions. They're the single character Unicode fractions. I guess they're called vulgar fractions. So specifically, if you ask it to do physics reasoning, which we are going to do as part of the benchmark test set, you'll see new characters being emitted, which is kind of an interesting finding. But first of all, how does it fit in overall performance alongside the other models that we care about? Now, in my opinion, the single most important curve for local model enthusiasts is the token efficiency graph, okay? And this is a graph that shows me for a given intelligence level on a benchmark set, like how smart is it, how many tokens does it use? And the ideal setting for me is if I want to let it think for a little bit longer, I'd like to be able to choose a different model that gets a better result. Maybe it takes longer, maybe it uses more tokens, and you can get a better result out. And of course, this has to be gated by the amount of VRAM that you have access to. So for me, on my $1,300 3090 machine, which is a pretty low-end device as far as running local AI goes, I want to see the intelligence level that I can get there. And how long do I have to let it think for that kind of performance? Here's the new efficiency Pareto Curve for 30 billion parameter class models. It's a very useful result, and it's not an interesting graph. How can that be? This graph is telling us exactly which model is the most intelligent for the least tokens, and there's only one point. Everything is dominated by Qwen 3.6 27B, the predecessor to the model that came out here. You can see that we do have a point on the graph for Qwen 3.8, and it just sucks. Qwen 3.8 gets a lower score, and it takes twice as many tokens. Get out of here. This is probably the most anticipated release in the Qwen local model series. I'm going to go out on a limb and say it was absolutely the most anticipated release. It's got 700 comments on Hacker News today. We're going to take a look at Twitter. The king of small models is back. Qwen 3.8 27B is open source. Day 0 support is an SG Lang. They're bragging about the decode speeds on 5090. It raises the bar again for what a small model can do on agentic planning and long horizon tasks. Did they use it? Did they try it out? Okay, here's another one. Paul Covert. I can't believe it. Qwen 3.8 27B is matching Opus 4.6 Max, the model that was the best and most expensive just 6 months ago. And you can run it on your laptop, locally, fully open weights, and under Apache license. This level of intelligence in such a small model is so impressive. Guys, we can't be trusting the benchmarks that were given to us by the company that is releasing the model. Anyone who has used a local 27B class model knows it's not as good as Opus. It's just not in the same class. Qwen 3.8 27B, you can now own unlimited, fully private intelligence, stronger than Opus 4.6 Max, with less than 24 gigabytes of RAM. Guys, you have to evaluate it on your task set rather than trust what someone else is saying about the performance of these models. These are getting massive engagement. The post that we just looked at before has 500,000 views. Okay, now that we've looked at the hype, let's take a look at one of my private eval tasks. Qwen is being asked to convert a Python script that's a calculator into some C code. So it gets to look at the code and then perform this translation from Python into C. So it goes off and it examines here's the reasoning. It's examining the Python code. It's confirming the environment. It's looking at the type of calculator and how it handles things like the modulo operator, number conversion, and stuff like that. And this is all great. And then if we get to the end, here at step 13, the model spent 25 minutes trying to call a tool. All right. So in the reasoning, clean build. Next, write the differential test harness. Great. Everything's going great so far. And it says, let's create the test files. And you can see here it's got some test cases. This all looks fine, but it gets completely stuck emitting zeros. And it emitted zeros for 25 minutes. This is 50 kilobytes of the character 0. Now, did Opus 4.6 Max have this behavior? How can you... I just can't understand it. So this is a really disappointing result. And I've seen smaller models, a 4 billion parameter model, a 9 billion parameter model. I've got a table here that I'll put up on screen. How often in the benchmark results that I have for a wide variety of models, how often a runaway generation like this occurs. And no other 30 billion parameter class model has done this, with the exception of Qwen 35BA3B doing it a couple times. So, and I have a couple other examples where Qwen 3.8 27B got into a degenerate output loop like this. I just can't recommend a model that is behaving like this out of the box. So guys, this makes me sad. I was really excited to get up early and I streamed on YouTube for the release. I was setting up the model and running it for the first time. And to be fair, it worked great for me on some simple tasks. I was setting up some infrastructure, I was programming a game with it, Super Dario, and I didn't notice the slowdown at the keyboard. So where does this new reasoning behavior bite the hardest? Difficult, ambiguous tasks. I saw the 3.8 go on for 30 minutes, never writing code. It was examining a black box. The equivalent run on 3.6 was committing, making progress, writing some code, running some tests, and the 3.8 never stopped investigating. Here's a task where Qwen 3.6 just wins. It's a hard task. The agent is given a black box program. It does particle simulations. You can set up some initial conditions and effects like gravity or charge, and the program outputs the positions of the particles over time. It's a neat example. It's hard for this class of models. I've never seen a model ace this problem, and it's part of my private evaluation set. So Qwen 3.8 spends 30 minutes of wall clock time trying stuff. It keeps running the program, setting up initial conditions. It's building a mental model of how the black box program works, but it never does anything. It never creates a Python script to mimic the code. It doesn't actually attempt solving the problem for 30 entire minutes. So maybe if it was given hours, could it do a better job? Probably. I don't think that's how I'm going to use a local model. I'm going to assume that it's stuck if it's doing a generation for taking turns for 30 minutes, and I'll probably intervene. Now, what did Qwen 3.6 do? Qwen 3.6, when given the same task, same prompt, same everything, the temperature, the top K, the harness, Qwen 3.6 decompiled the binary. It inspected the binary, going effectively line by line, found the branches where the evaluation code within the binary was applying the physics effects. And so Qwen 3.6 determined accurately the charge and gravity and other effects that the black box was using. And it cranked merrily along and wrote some Python code, and it didn't get everything right. It scored partial credit because it didn't get the same exact behavior as the black box program. But this is a case where Qwen 3.6 is just better. So, that said, it's definitely a more capable model in some cases. And we're going to cover 3 concrete examples where Qwen 3.8 is able to complete a task that 3.6 just can't. And these aren't hypotheticals or multiple choice. These involve vision primarily. We already went over the case where we were sending MP4s into the model. So just real quick, this is grabbing a image of a chessboard and sending it in to the model. This is the 3.8 version first, and we'll see that it gets an almost perfect fen back. There's an issue with the placement of the knight on the second row, but other than that, it does a great job. And then we're going to do the same test by just doing a post request to our llama-server endpoint after we switch to the 3.6 version. And from what I can tell, the 3.6 is just, it's incapable of doing it and doesn't return a valid response at all. So this is a clear win, and I saw increased ability to do vision tasks across the board. We're going to take a quick look through the linguistic weirdnesses that Qwen 3.8 has, because I promised that earlier in the video. If we see an orange bar here on this graph, this is indicating a character that exists in Qwen 3.8 and does not exist in 3.6 reasoning traces or output. So we got the horizontal ellipsis, we have a middle dot, the less than or equal to sign. What really jumped out to me were these like superscripts, like the cubed or the vulgar fraction, where it's just one character that is a 1/2 fraction. And then there's other arrows and mathematical notation that's new with Qwen 3.8. Not too consequential, but I just think interesting. And it has a massive propensity to emit M dashes, so much more than Glimmer, much more than the 27 billion 3.6, and it's more in line with Opus, I think. Article drop hits, so this is emitting articles like a or to or an or the, and Glimmer's the undisputed king of that. And then copula drop hits, this is when you drop something like an is or a was, like a glue verb, and it doesn't really do that at an exceptional rate like Glimmer. It does seem to have fewer pronouns in general. And again, orange is Qwen 3.8. So it's just using pronouns less, and people might be interpreting this as why, because I'm seeing people say that it is acting like Muse Glimmer with the Grug Brain really terse style. It says stuff like let me less often, and it does a lot more hemming and hawing with and wait and let's reconsider and stuff like that. Guys, closing thoughts here. When we're talking about the successor to such an incredible model, the 3.6 27B is arguably the most popular coding model for a 3090, a 4090. And when you're talking about a successor that thinks twice as much on easy tasks, intermediate difficulty tasks, on hard tasks, when it has to generate run-on token problems, when it does worse on some very hard tasks by just reasoning way too much, this is a failure, and it's not a good model. This is not a good release. Now, if this was the only model you had ever encountered in your life, and you saw this thing write code, and you were like, "Wow, this is amazing! It's creating apps for me," like that's one story. But it's coming on the heels of being it's being evaluated as the successor to the best model out there, and it doesn't meet the bar. So this is a disappointment. I'm going to continue evaluating this because it's possible that my setup is just suboptimal. But there's a lot of people online saying the same thing. This thing reasons a lot. And I think that if people took an honest look and an honest evaluation at their wall clock time, at their token generation, at their token counts for solving a particular problem, if people who are running local models, and you should do this and comment about it and send me messages about it, but it doesn't measure up and it's not close. So let me know what you think. I'm gonna start adding a privacy tip to the ends of these videos, and if you enjoy this content, I would recommend downloading a free open source ad blocker like uBlock Origin. Prevent loading some ads, prevent sending some of your data outside of your local network. So do that if you don't already. So, all right, see you in the next one.